Hello friends, welcome to engineering tutorial. Now in my previous video we discussed about the current division rule. Okay, we discussed about the expression of current division rule and also the mathematical derivation of those expressions. So today we are going to discuss about the voltage division rule, another concept related to electrical circuits, a very useful concept. So in current division rule we studied that it is applicable only for parallelly connected resistors, that is resistors connected in parallel, and is used to determine the currents flowing through each of the parallelly connected resistors. In a similar way, the voltage division rule is applicable only for series connected resistors. That is, we can only apply this law, this rule, for resistors connected in series. And why it is used? To determine the voltage drop across each of the resistors which are connected in a series network. Okay, this is the voltage division rule. So what we have taken is a normal series connected network, resistive network, which consists of two resistors R1 and R2 connected in series. You can say that they are connected in series because they are connected in an end-to-end fashion, with the right end of resistor R1 connected to the left end of R2 and the extreme ends are connected to the terminals of the voltage source V, the extreme ends of R1 and R2, the other extreme ends. So it's an end-to-end connection pattern. So these R1 and R2 are connected in series. Here VR1 and VR2 are the voltage drops across resistor R1 and R2. Again, pay attention to the polarity that we have given, plus and minus, because current always flows from positive to negative in any resistor internally, because the resistors, they always absorb power. So the voltage drops are given in this fashion. Now what the voltage division rule says is that the voltage drop across this resistor R1, that is VR1, can be determined by this formula, V into R1 by R1 plus R2, where V is the supply voltage, the DC supply voltage, multiplied with the same resistance across which we have to determine the voltage drop, divided by the sum of the two resistors. Similarly, the voltage drop across R2, VR2, is equal to V into R2 by R1 plus R2. So here, the numerator in both of the expressions is constant, it is the same, only there is a change in the numerator. So whichever resistor you have to determine the voltage drop, you simply multiply the total supply voltage with that resistance divided by the sum of the resistors in the network. Here there are only two resistors, so R1 plus R2. So now let us see how we got these two expressions, how to mathematically derive these two expressions of voltage division rule. So now we will mathematically derive the two expressions of voltage division rule. So we have taken the same series circuit containing two resistors R1 and R2 in series across a DC voltage source V. Now, capital I is the total circuit current. Now it can be calculated by this expression. Total circuit current is equal to the total voltage V divided by the total resistance or the equivalent resistance. Now we know that the equivalent resistance of a series connected circuit is the sum of the individual resistances. So it is V by R1 plus R2, the total circuit current, as there are only two resistors present. So the total circuit current I is equal to DC supply voltage divided by the total equivalent resistance, which is V by R1 plus R2. This is equation number 1. Now, the voltage drop across resistor R1 is simply the product of the current flowing through it, that is I, multiplied with the resistance itself, R1, I R1. The voltage drop across R1 is I into R1. The same current I flows through resistor R2 because they are connected in series, and the current through a series circuit is the same. So the voltage drop across R2, that is VR2, is equal to I into R2. Okay, this is equation number 2. Now, if you put this equation 1 in equation number 2, we can get the expression of voltage division rule. So we have to substitute the value of I, that is V by R1 plus R2, here in these expressions. VR1 is IR1 and VR2 is IR2. You have to substitute this value of I. So VR1 is equal to V by R1 plus R2, that is I into R1, and VR2 is equal to V by R1 plus R2, which is I into R2. We have just substituted this value V by R1 plus R2 in place of I, and we got this expression of voltage division rule. VR1 is equal to V into R1 by R1 plus R2, and VR2 is equal to V into R2 by R1 plus R2. So we mathematically derived the expressions of voltage division rule. Another very important thing related to voltage division rule which have to be taken care of, and mostly mistakes happen while applying the voltage division rule, because is that students confuse voltage division rule with current division rule and current division rule with voltage division rule, which I have already mentioned in the current division rule video also, is that it is very easy to make this mistake of while applying the formula or expression for the voltage drop across R1 and R2. So what students do is, while calculating the voltage drop, they apply this formula. VR1 is equal to V into R2 by R1 plus R2, and VR2 is equal to V into R1 by R1 plus R2. Now this is similar to current division rule, where to calculate the individual branch currents, we multiply the total current with the opposite resistance, the other resistance. But it is wrong in voltage division rule. It is wrong. In voltage division rule, you have to multiply the total voltage, the supply voltage, into the same resistance across which you have to calculate the voltage drop. That is, VR1 is equal to V into R1 by R1 plus R2, and VR2 is equal to V into R2 by R1 plus R2. So because the formula is similar to current division rule, most of the time students mix them up. They interchange voltage division rule with current division rule and current division rule with voltage division rule, and that's why it is very easy, it's very natural to make this mistake. So you can practice this formula by writing it off many times and applying it many times while solving problems, and it will come up. It will get to you. So this is an important thing related to voltage division rule and also related to current division rule. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to electrical, electronics, instrumentation and communication engineering. Have a great day. Thank you very much.